Next topic is called acceptance sampling. Acceptance sampling is a screening activity. It does not add quality to a product, existing product. Acceptance sampling is about taking a sample from a lot of parts, testing only the sample, and making a decision about the lot itself. So, for example, you have a vendor, and from the vendor you order important parts for your production. Maybe you produce computers, and then you order some component, some chipset from a vendor. So they send lots, say 1,000 units at a time or 5,000 units at a time. Now you have to decide whether to accept the lot or not. So one way of going about this is to inspect each and every part, keep the ones that are good, and throw away the bad ones. Okay, that's 100% inspection. But this 100% inspection sometimes is not done for a couple of reasons. One is if inspection requires you to destroy the part. Suppose if the chip that you're getting from the manufacturer, you have to break it in order to test whether it is good or not, then you cannot do 100% inspection. If you did, you will break the entire lot. So you have to take only a random sample from that lot and test only the sample. Another case would be 100% inspection may require a lot of time and may be expensive, and it may not be required. You can control the quality through judicious use of sampling. Okay, so one is when it may be infeasible to do 100% inspection. On the other, it may not be cost and time effective. Maybe sampling would do just as well or almost as well as 100% inspection. So that's the reason why you would do that. So there are two key questions that we need to answer. One is, how big a sample should you take from the lot? From the lot, you take a random sample of n items. So what should the value of n be? Should you take 10 items or 20 or 50 or 100? What? Then we inspect each of these items in the sample, and we reject the whole lot if there are C or more defective items in the sample. C is the critical number of bad parts in the sample that we have taken. So how big a threshold value you want to set for C? Okay, you want to be very strict, you can say 0. Okay, even if you find one bad part in the sample, you're going to reject the entire lot. Or you can say, all right, I will allow just one bad part, or 2 or 3. So these are the two numbers that we have to come up with, N and C. How big a sample and how small a threshold should you set beyond which you will reject the entire lot. So that's called the sampling plan, N, C. When you reject, you can return the entire lot back to the supplier, or you can, if it is feasible, okay, you can do 100% inspection and cull all the defectives and keep only the good ones. Or maybe you can regrade the lot into a lower specification lot, if that is feasible again. To decide the values for N and C, we have to first understand what is called operating characteristics curve for a given sampling plan. So once you have N and C, then you can develop an OC curve, operating characteristics curve. We don't know the N and C value yet, but let's try to understand what this OC curve is, and then we will go back to finding the correct N and C. So it shows the relationship between probability of accepting the lot on the y-axis and the quality level of the lot. Quality level meaning what percentage of defectives are in the lot. Okay, so percentage of defectives in the lot goes in the x-axis, and the probability of accepting the lot goes on the y-axis. Then you compute for different values of defectives in the lot, what will be the corresponding probability of accepting the lot for a given sampling plan N, C. Okay, shows how well a sampling plan discriminates between good and bad shipments. An OC curve will look like this. Okay, you have 1% defective, or 0% defective. If the incoming lot has 0% defective, of course, probability of accepting the lot will be 100%. So that's the starting point. And then as the proportion of defectives increases to 1%, 2%, 3%, and so on, the sampling plan will accept the lot less and less. The probability of accepting the lot will go down in this way. So now we have to calculate these probabilities, and we should be able to plot the curve, and we will go through an example like that in just a second. But once you have an OC curve, then you can think of how to apply it. And there are two numbers that are critical here. One is called AQL, acceptable quality level, and this is the poorest level of quality which is still acceptable. Of course, you want 0% defectives in the lot. That's what you desire as a customer, but that may not be possible or practical. So you may want to accept, say, 0.5% defective will be good, or 1% defective will be good. So what is the highest level to which you are willing to go? 0% is the best. So how far up you are willing to go and still say, okay, so up to that level, the lot will be considered good. So AQL is the limit for the defective percentage to go, up to which you will say, all right, I will accept the lot, because that amount of defectives I should really be able to tolerate. Then the other side is lot tolerance percent defective. So what is the quality level at which a lot will be considered really bad? Okay, from the consumer's point of view, from the buyer's point of view, if you hit like 10% defective, then that is really a bad lot. That is called LTPD, lot tolerance percent defective. So let's look at how these two numbers work. A perfect sampling plan would be, if this is your AQL, acceptable quality limit, so up to your sampling plan should be able to discriminate that, and up to 10% you should be able to accept the lot, and beyond 10% you should return the whole lot. But there is no such sampling plan available that will discriminate so clearly, because we are relying on samples. When you get a lot, and when you reject a lot, or when you accept a lot, there is a possibility of making a mistake. So there are two kinds of risks that we will face. One is called producer's risk, and that is, we have agreed, the producer and the customer have gotten together and they have agreed AQL as the defective up to which the lot is considered good, and the consumer should really accept the lot, right? So like 1% defective or 2%, whatever the AQL value may be. Now we don't know, when a lot comes in, we have no idea what the percentage of defectives in the lot is. We're going to rely on the sampling plan. Now, hopefully the sampling plan is discriminating enough that if the proportion of defectives in the lot is AQL or less, you will accept the lot. Okay? But off and on, hopefully not too frequently, the sample may contain more defectives than C, then you end up rejecting the lot. So there is a risk of that happening. That is called producer's risk. Okay? Producer sends in lot, and the producer knows that most of the time, if the defectives is less than AQL, it will be accepted. But there is a chance that it may not get accepted. So again, through negotiations, you will set a limit for producer's risk. Producer then says, all right, AQL is 1%, but I'm willing to accept the risk of rejection of AQL, say 5% alpha. And similarly, on the other side, on the LTPD side, we know that when the lot has LTPD proportion of defectives, is really a bad lot. You want to make sure that the sampling plan is discriminating enough to reject it. Most of the cases it will do so, but sometimes you may not detect that. Your sample may contain less than C, less than or equal to C defective, so you end up accepting the lot. So probability of accepting a bad lot, that is called consumer's risk, and that is beta. So this is what the OC curve will look like. So under normal circumstances, this is the curve, and this is supposed to be good lot, AQL, but by the time you get to AQL, the probability of accepting has declined a little bit. So this is the probability of accepting the lot. So there is a small chance of rejecting the AQL lot. So that's your producer's risk. And usually you'll set it at 5%. And here is the LTPD, which is really a bad lot, and you want to reject it, okay, and the probability of accepting the lot is really small, but still it is not zero. So there is a level of probability of accepting this lot, and that is consumer's risk, 10%, or this could also be 5%. So there are four numbers that we need to look at: AQL and alpha, producer's risk. So that defines 1 point on the OC curve. And then LTPD and beta, the consumer's risk, that defines a second point in the OC curve. Now, based on the agreed upon numbers for AQL and producer's risk and LTPD and consumer's risk, you want to find a OC curve, or you want to find a value for N and C, the sampling plan, whose OC curve will pass through these 2 points. Then you have a good sampling plan that is acceptable to both the consumer and the producer. So that's the task. Here, if N increases, if you increase the sample size, then the probability of accepting the lot will go down. If you increase C, the probability of accepting the lot will go up.